Hello, this is video X. It sounds pretty ominous, but this is the one we've been waiting for. This is where all the magic happens, also known as the implementation file for the TV class, Tv.cpp. implementation. Two separate pieces, remember. TV.h was our advertisement, our billboard. Said if you want to use a TV object, this is how you do it. This is secret stuff. Nobody knows about what's going on in here except for us being the developers of the TV data type, the writers of the TV implementation code. And in the header comments, line 5, it says that it's the implementation, which we think of as this is the secret stuff. We're behind the curtain now. Now, again, this is a two-way thing. Not only is all this stuff in this source code file, tv.cpp, which I hope you either have open on a separate window on the screen so you can look at that and look at the line numbers as I talk about them, or have it printed out. I got off track, so I forgot what I was going to say. But let's look at the includes. Seen those before. Quick review. Include tvh inside quotes means find a tv.h file in the same folder where I am right now. Include IOStream means look over there and wherever you're keeping all of the standard library include files. So nothing new there. The first new step, or the first actual code that we got here, whole list of symbolic constants that are visible only, since they're in this file, these are visible inside tv.cpp only. They're not even visible in the header file. So this is the beginning of our own secret business down here. We as a TV object know that our maximum channel is 13. The main program has no way to figure that out except perhaps indirectly by changing the channel over and over and see how high it will go. If we wanted to expose that, we could put another member function and do it, but we didn't. The maximum volume it can go up to is 10. It's got to be at least channel 1, at least volume 0, and then a couple of kind of mysterious ones perhaps. Init channel. Initial channel is 1. Initial volume is 5. And we'll see those in action pretty quickly. But for now, just make a note that even though there's the symbolic constants, and even though they're way up at the top of the file, those are only visible inside where we are, the .cpp file. Everything here is a secret. Ooh, let's get even more secret here. There is our first example of a constructor. Line 22. There's a mess there to try to explain. I'm going to go to a simpler function. How about a one-line function? I'm going to look at line 41, and that is so messy and cryptic that I'm going to write it on the board and annotate it. Line 41 starts off with int. Easy enough, we can handle that. Then it's got TV, : holy moly, : get channel. Let me make sure I've got, this line 41. Line 41, get channel. And then in parentheses, void. And then const. And an open curly bracket. You know what? That's such a short function. Is it still recording? This is the second time for this video too. So if I leave something out, please let me know. I probably said it in the earlier version of this that crashed. Return channel. I'm going to try to answer in it. Whoops, that was a curly bracket. Every possible question I can think of about this function. This is where the class interaction would really help a lot. Bless my heart. But we're not here, so we can't do that. Int, we know int. We've seen int. First of all, this is a function. I hope we know that and recognize that as such. It's a wild and crazy function with a bunch of new stuff, but it's still a function, a little one-liner. That's why I chose that one to write on the board instead of the others. This is the function return type. This function will return an integer to whoever calls it on a TV object. You can't call it disembodied, just get channel, whatever you want. I don't really care what TV it's on. You can't do that. It has to be called on a specific TV object, or the function is not defined. Return type. Function return type is an integer, send back a whole number. I've worn that out. Here's some new stuff. This is talking to the compiler. What does it say to the compiler? Says this function is a member function of the TV class. That's precisely what TV : says. It says, this is a member function, abbreviate FN, of the TV class. If you want to be a member function, you have to proclaim yourself as such. You have to have TV : out front of yourself. Otherwise, you're just a plain old function. If I got rid of TV : it would still be a function get channel, but there'd be a problem that I'll point out in just a second. See if you can hold that thought. I'll see if I can hold that thought. I don't know where I'll hold it. This is the function name. Been there, done that. We know what that is, function name. Void means receives no parameters. Void. Const. That's new. We saw that in the header file. It also has to be const down here. In other words, it's got to match the prototype exactly. The only difference between this and the prototype is when we're down here in the CPP file, we have to separately say that, yeah, we're a member function of the TV class. We're not inside that huge set of curly brackets in the header file where everything is automatically part of the TV class. If we don't put TV : down here, the compiler doesn't know that this is supposed to be a member function. So this const says, I'm an accessor. And that function sounded pretty excited to say that. I'm an accessor. But what it's really saying is there's a bunch of stuff I can't do. I can look at the private variables if I want. Can't change them. Const says, look, do not touch. All the pieces. It's going to return an integer. It's a member function of the TV class. Here's the function name. That's what the main program will have to use to call it on a specific TV object. It's not receiving any parameters from whoever calls it, the main program or whoever else might want to call it. And it can't change anything. It's const. It can't change, specifically, it can't change any of the private variables. Return channel. That's the only place, except for a piece of the function name here, that's the only place I see that on the board. This is not a local variable. There is no variable inside here that says int space channel semicolon. There better not be. That would be a horrible mess. This says return the value of private variable channel. Even though the variable itself is invisible to the main program, it's not invisible to this function since it's a member function. And if it wants to grab the current value out of channel 9 perhaps, and send the 9 back to the main program, then it can do that. This is private variable. If you don't believe me, look back at the header file. You'll see a variable called channel inside the private section. Now, I'm not even consistent with my own terminology. I'll occasionally call it private variables. It is a private variable. I'll occasionally call that a state variable. It is part of the state of the object. State variables are private. Are all private variables state variables? Yeah, I believe they are. So they're kind of synonymous, even though the word itself means something a little different. Now, back to where I was. Am I temporarily going to X this out? Yeah, I'm temporarily going to X that out. This has got to be one of the top 5 errors when you first start writing classes of your own. Oh no, the compiler's yelling at me, undefined variable channel, it doesn't know. And it's up there in the header, and I included the header, yada, yada, yada. Why can't it let me access variable channel? I'm in that club. Well, no. If you didn't put TV : you're not in that club. If you don't have TV : out front, like I said, this is a plain old global function visible to the world that's not part of any specific class. It's not part of the TV object. It's not part of the TV data type. In which case, it cannot access the private variable that is part of the TV object. You want to see the private variable values channel's value, you've got to be a member. So if I can strategically un-X that out and put it back there. Well, that's ugly. I'll rewrite it. In case I need to say something else about it. TV : makes you a bona fide member of the TV class with all the privileges associated therewith, including being able to see the private variable values and send them back if you want. This tiny little one-line function packs a punch. It's a member function. Our first member function to look at is an accessor, no parameters, returns an integer. What integer? It returns the current value of the channel variable. It's not allowed to change it. If I say return channel plus plus, the compiler won't let me get away with it because of const. I can't change the value even though I can look at it. I don't know what else to say about that function. Is that it? I think that's all of it. You can see the channel without being passed in. Yeah, I already said that. If you got questions, please jot those down to the side, and you can email me or bring them up in a Zoom session. Now then, now that I got all that, I think maybe I can talk about the constructor without writing it down. Remember, up there on line 22, that is the constructor. You know what? I do need to erase this so I can write that down. Do not, repeat, do not let me do hand waving and say, well, I don't need to talk about that. I do need to talk about that. TV, : TV, void. If nothing else, I need to talk about that much. Now, why did I talk about the other one first? It was easier to explain when I didn't have the apparent repetition here. These two TVs mean something different. That means this says, here comes, honey boo boo, here comes a member function of the TV class. Here it comes. It's going to follow the second colon. Brace yourselves. TV : declares whatever function follows to be a member of the TV class. This TV means something different. Do we remember? Yes. The name of the constructor has to match the name of the data type. So I'm going to call this required, R-E-Q-U-I. I'm even spelling it out. Ooh, it must be awful important. Required name of TV classes. That's possessive, not plural. Required name of TV classes constructor. What else do we know about constructors? Quick review. We never call them. Only indirectly. If we define a new variable of type TV, the system calls this, but we never call it ourselves. It is a member function, bona fide member function of the TV class. It has to have that name. Constructor is the same name as the data type. We're not passing anything in. How could we? We're not going to call it. The system does it. What about the rest of this stuff? Is there anything we need to do? Well, it turns out, yeah. We don't want the channel to be garbage when a new TV object is made. We want it to be something. And there is our symbolic constant init channel. The TV, when you turn the TV on, it automatically sets to channel 1. See how that works? We're setting the private variable values. You will always want to do that in your constructor. Don't let your private variables be garbage. Don't let that happen to you. Set them to something, not necessarily symbolic constants. Maybe we set them to 0, but we want to set it to something that we can predict. In this case, I'm setting the channel to init channel, which is 1. I'm setting the volume to init volume, which is 5. There's not necessarily any logic to that. Maybe I could have set initial volume to 0. Probably wouldn't want to set it to 10. That'd be somebody else's TV and not ours. But I set the volume to 5 and the channel to 1 just so I know for sure what they are. Now, here's part of my heartbreak of splitting this up into separate videos. Do you remember back in the day when I talked about the preprocessor define up in the header file, and I described debug as saying, debug, you now exist. Either you exist or don't exist, depending on whether or not I hit that define. If, since I'm including the header, and that's copied and pasted at the top of this file, just as it was in the main program, if I included the header and debug is defined up there, then my preprocessor directive on line 25 says, you know what? If debug is defined, that I am compiling, I'm going to compile this program in debug mode, meaning I'm going to produce some extra output just to see what's going on. I'm very new with constructors. I don't know if they work or not. I'm not sure the system's calling it for me. So I'm going to turn debug switch on. I'm going to define debug. And here, line 25, when it gets there, it finds out, yeah, debug is defined. So it's going to put the cout statement in what's called the compile buffer. It makes that an official line in my program. If debug is not defined, it's as if lines 25 through 27 are not even typed in at all. It's like they're completely gone, completely disappeared. It's called conditional compilation. It's not an if that, like at runtime, where you test the value of a variable or test the name somebody typed in to see if it's a sentinel. This if and end if actually changes what lines are in your program. If we have defined debug, then it puts that C outline in our program. If we haven't defined debug, I think I just got cut off. I don't know. I'm going to try to keep going. If I haven't defined debug, it does not put that C outline in my program. Now, why do we even have mechanisms like that? That way, when you're working on your program and you've littered it with all these extra C outs so that you can see what's going on, you can use that define debug and then the if defs later on, and you don't have to erase those, which is going to be real handy if all of a sudden you realize, oh no, I made an error I didn't realize, and I got to go back and turn debug on again. It really is like a light switch. You can turn it on and off. When it's on, you see all the extra C outs. When it's off, then it's business as usual. Now, by business as usual, I mean unless. This is an important point that I'll hit you with later, over and over again, whenever we're writing our own classes. Unless it is the job of a member function of a class to read from the keyboard or print to the screen, then don't do it. All of a sudden, you've made your class useless for any other programs. Let me repeat. Unless it is the specific job of a member function of a class to read from the keyboard or to write to the screen or both, then do not do it. It's not even a good idea, like I have on line 8. The only reason I've got line 8, include IOStream, is for the debug example. Printing out the cout stuff, howdy from the TV constructor. Oh, a cute little message. That's the only reason I've even got IOStream there. This class, when it's cleaned up and when it's debugged, it has no business reading from the keyboard, writing to the screen. How many times have I said that now? 5, 6? Maybe that's enough. What else we got? Okay, since debug is turned on, it is going to put that line in there and it's going to print out howdy from the TV constructor. Why would I want it to do that? Well, I might not trust the system to call my constructor when I set up new variables, and I want to see if it's doing it. So when you compile and link and run this with example 8.cpp in one big project, I'll probably have to have real short videos to show how to put that together. It really is just a matter, here's what you do if you're working on code blocks. You set up a project, you put example 8.cpp in there, and you put tv.cpp in there. 2 files instead of 1. And voila, compile and link and run, and it should work. Cross fingers. Unlike my computer, which is giving me all kinds of messages, it just connected and reconnected. I'm sorry about this. It must be dropping out all the time. Okay, the destructor has to have the tilde sign. It has to be a member function. Thus, line 31. Line 31 says, here comes a member of the TV class, and it's the destructor. The tilde out front says that. I don't pass in any parameters. All that's in there is a debugging message, just to see whether or not my destructor ever gets called by the system on my behalf. If the debug is turned off, then the destructor is completely empty. I'm pressing my luck. I don't even know if it's still recording now. I'll pretend that it is and quickly look through this, and I might have to add a video to the end of this one as well. Set channel up. If you look at set channel up, starts on line 52. I hope there's nothing mysterious there now, except that there is no word const. There's no word const, which means this is a mutator, and it can change the value of private variables, and it does. It starts off by ++ing channel. A channel is 8, now it's 9. If it were 10, now it's 11. If it were 13, now it's 14. Oh no, channel 14 is not allowed. If I leave it 14, that's on me. That's my fault. I'm a member function of the TV class. Well, look at this. Let's say it is 13. Then when it gets to line 54, if I plus 13 on line 53 and now it's 14, 14 is greater than max channel, and it does a wraparound. If channel is too big, then set channel to the min channel. That's what's called wraparound. If you get to 13, go way back to the beginning, and now we set the channel to channel 1. There's wraparound in the other direction on set channel down. I start off by decrementing channel. Let's say channel is set at channel 1. If it's at channel 1, and I do minus channel on line 59, now channel is 0. That's not allowed. If I leave it that way, it's my own darn fault. So look at line 60. If channel is less than min channel, in other words, it's less than 1, then I wrap around and set channel to the max channel. I'm afraid this is probably all for naught. I hope I can remember what I didn't say when I record this video again. Okay, the last two functions, set volume up. That's different. That's different from setting the channel up. I only increment the volume conditionally. If volume is less than the maximum volume setting that's allowed, then I'll increment it. Otherwise, I'll leave it alone. I think the max volume is 10. I believe it is. So if I get up to volume 10 plus volume, then once I get up to 10, it doesn't go any higher. I'll have to bring it down using set volume down. If volume is less than the minimum volume, then I'll decrement it. So as long as it's less than 10, no, I'm sorry. If volume is greater than minimum volume, I was looking at the wrong condition. The minimum volume is 0. So in other words, if volume goes, we're going to go negative, if volume is great, I'm just worn out, I'm sorry. Let's look at set volume down. Let's pretend like we haven't looked at that at all. We get here and the volume is 1, let's say. Volume is greater than min volume. That is greater than min volume because min volume is 0. So it will decrement volume down to 0. Your baby brother's playing with the remote, and even though the volume is completely muted now, it's all completely turned down, they hit the down volume button again. If they do that and we get back here on line 73 and volume is already 0, then it's not greater than the min volume and it does not decrement it. It will not let it go negative because that negative volume doesn't make any sense for a TV. I might have to record an additional video on Tv.cpp or a replacement video, as the case may be. I will review this before I put it online to see if it's broken or frozen or whatever. But at any rate, that should be, I hope, enough of Tv.cpp that you can look through that and try to make sense of the rest of it on your own. Please write notes off to the side or on separate paper. And by line number, it'll be a lot easier for us to have a discussion about what still is mysterious to you in any of these. Example 8, tv.h, tv.cpp, any of those that are still mysterious. If you can zero in on specific sections or line numbers or whatever, then it'll make it a lot quicker for us to have a discussion and try to solve the problems. Okay? And until then, I'll see you online.